Welcome to the tutorial. So here today tutorial is based on strain, tensile strain, compressive strain and shear strains. So what is actually strain? How we'll define it? So let us consider first what is a strain. So if the elongation per unit length in a longitudinal direction. So here we are considering the longitudinal direction of a solid body, which is known as longitudinal strain or simply strain. So how it will happen? Here we can observe the one member, solid member, which is, if this member is subjected to all loading conditions, at tensile loading conditions, what will happen? Due to tensile load, the length of the solid member will increase, and this is increase with delta, as this is here indicated, increase with delta, and the total length will become now L plus delta. So what will happen? Here earlier length was L, now increase will happen that by delta. So if delta is elongation of the body of the length L, so what is the strain? So as we define the ratio of change in length by original length. So here whatever changes happened, that changes is delta. So here you can write the delta divided by L. Before that, need to see the what is the symbol. Epsilon is the symbol of strain. Original length is given L, change in length is given delta. So this is changes happening here. So here finally it is given as epsilon is equal to delta by L, means change in length divided by original length. So next we will move to tensile strain. So what is the tensile strain? We will see. Here consider a solid member which length will increase under axial tensile stress. Tensile stress, that is nothing but a load, because due to loading a stress will produce. If a stress is produced, means the changes will happen. So here a stress will result increase in length. So here we are talking about tensile strain, means tensile loading condition will be there. So increase in length of member from L to L plus delta. So here delta is the increase in length. So here delta is the increase in length, that is shown here, is the actual deformation of solid member. So this is the actual deformation delta. So the tensile strain is ratio of actual deformation delta to the original length of the member. So here as a tensile force is applied, due to this tensile stress will produce. What will happen? The length of the member will increase with a delta. This is a delta, it will increase. So in same way here tensile load is applied. So here E of T is equal to delta by L. So we can define the tensile strain. So this is produced due to tensile force or tensile load at the end of solid member. So we can define this in this fashion. So next, now going for compressive strains. So how we are going to define the compressive strain under application of compressive load? So here we are directly talking about compressive load. This is also an axial load which is acting in a longitudinal direction. A solid member length will reduce from L to L minus delta. So with amount delta the length will decrease. So here original length is L and delta with delta is decreasing. So what will happen? In same fashion we can define the ratio of change in length, that is delta, then the original length. So here compressive strength will be defined in this fashion. Next we will see the shear strain. How it's going to define? how it's going to define the shear strain. With the application of shearing load in the sense, if you have a block, so here we have been considered a rectangular block, and what is happening at the bottom, it is fixed, and at the top, at the top at left corner, one force is applied in the longitudinal direction. Force is applied. Due to the application of force, what will happen? So as the bottom is fixed, the upper portion is going to move, and it will make a angle phi. It will make angle phi because distortion is happening due to the application of load P. So it is measured by an angle through which the body distorts, means distortion is happening. So here how it's going to be like now, so it's shown with a dotted line, so it's going to be like this. So in that results, what will happen? In a rectangular block, L, M and P that we have taken earlier, fixed at one face and subjected to force P at up left side of the up corner. Due to the application of force, the rectangular block will distort with an angle phi and maintain new position. So new position is maintained. So L, M dash and dash P will be the new positions. So what will happen? So here shear strain. So we will indicate that shear strain ES. Shear strain is ES. So ES is equal to that phi we are thinking about. So N dash. So this N dash divided by NP this one, and that will be equal to 10 phi. So here we will take phi in radian, but ultimately what will happen? What will happen that the phi is a very small. So that's why we will consider 10 phi is equal to phi. So here finally the shear strain will be ES is equal to phi. So that's the end of this session. Thank you for watching.